People watching this video response, what I got from it was it got this nice little drawing, and you can see it on the picture, of the magnetic field, how it's hit from the sun. You can see the arrow, the sun hits it, yeah, at the front. There's the normal one at the front, the magnetic field at the front, and because the sun's shooting particles at us all the time, we get this trail off the end like this, and it all trails off the end. Whereas actually, in a 3D world and a 4D world and anything more than a two-dimensional Einstein world, because Einstein's gravitational fluxy crappy stuff is two-dimensional, that's Einstein, this is the future. Alright, so we get a bit closer, and we've got the direction of rotation around the sun, not the direction of rotation of the planet, because I haven't put that in. Right, on top of this drawing which I've put here, which is better than his drawing, yeah, on top of their drawings you've got the fact that the Earth is going in that direction. So you've got the sun's particles coming in this way, which is forcing flux off the back of the planet going that way, which is similar to that, if you can imagine it being like that, yeah. But you've also got the rotation of the planet and the fact that the planet's going that way, so it's leaving the flux going that way as well, because you've got the 3D bits going, not just the 2D bits. And then when we get the fact that the planet's spinning around as well, it gets even more complicated. And unfortunately, everybody seems to be missing these things. They seem to be doing things one at a time, one bit at a time. You've got to step ahead and think a little bit more. I think they say thinking, lateral thinking. Well, we were talking about 4D space. What's 4D space? 4-dimensional space. What's that? 8-dimensional space. What's that? Oh, I forgot to get another piece of paperwork out for you, he says unconfidently. Maybe it might be here. Not. We don't even represent the magnetic field properly. When we draw the magnetic field, we haven't actually completely understood all the dimensions of a magnetic field. We're working in the 12 dimensions at the moment, and I know there's still more dimensions than 12 within the magnetic field. And we're just working in 3 and 4 dimensions at the moment and saying, oh yeah, there's no force and no free energy in magnets, and there's nothing you can do with them. I can see you're pushing it, but anti-gravity means collapsing gravity. What we need to be working on is self-gravitating devices. Do you understand? Self-gravitating, creating a gravity. Not create something that destroys gravity, anti-gravity, or something that repels gravity, repel gravity. We need to be creating a device that creates its own gravity. And then we can go out into space with a device which creates its own gravity, and then we can shape the gravity to propel ourselves instead of being propelled by, let's say the Earth is propelled by the sun's gravitational force. We need to create our own gravitational force and then shape it so we can thrust ourselves through space within a self-gravitating field. So we need to create our own self-gravity, self-gravitating fields. A self-gravitating device which creates its own gravity field, not an anti-gravity field. We don't want to be attracting ourselves. It's like a magnet. You get a magnet and a piece of metal, it grabs itself to it. That's like plus. You got a gravity field which is a positive, and you got an anti-gravity which is going to come together, isn't it? We all know a positive and a negative come together. We need to build another gravity. Yeah? And not to repel that gravity, because we need to be able to get onto that gravity and land on it and then get back off it again. So we need to be able to self-gravitate and then shape the gravity. So when we're coming in towards the other body, which is the Earth's surface there, yeah, we can come in towards it and then slow down, stop and land gently. Once we've done what we want to do, then we can get it off the planet again by reversing, or no, shaping our gravitational forces so it's gets us off. It's not getting us off. We're now floating, not floating, we're now manipulating ourselves in the web of gravity, whatever you want to call it. We're becoming another celestial body, separate from that. So leave that one alone, that's been affected by the sun. Let that one go away, and we'll just stay where we are. Because we're our own body in space now, we're our own sun. We're our own singularity. We can do what we want. And we shape ourselves, like a singularity just flies around and, well, there's a sun, let's go and eat the sun. Yeah, it was a nice sun, right, next one, off we go to another one. No, they're even controlled by bigger forces. We need to separate ourselves from those forces, not anti. We need to make a gravitational field that's strong, that when we come into a singularity, we don't get dragged into it and go, whoa, hold on a second, that's a black hole. Let's stop, turn around, and come back out again. That's what we need to do. And we can do it. But when we're talking about anti-gravity, we're going to have an anti-gravity device, which we think, oh, it's bling, it's anti-gravity. And we're going to follow this massive gravity, yeah, and it's going to be like straight into the black hole and destroyed. We don't need to anti, we need to make a, on the positive, two positives repel, yeah? So, not anti-gravity, self-gravitating. We don't need to make an anti-gravity, we need to make a self-gravitating device. I should think we get there somewhere. Even if you only get 2 minutes of that, it's alright. There's a pointing in the picture. There's a picture, there's a pointing, and this one's better. Let's draw another one better than that. I'm going to draw one even better than that. This one was wherever you're at, 2D, 3D, 4D. This one's even further. This one's explained it a bit better. I'll cover that up. That one's better. And imagine there's a fluctuation in the planet. It isn't a perfect plane. It's always fluctuating up and down. So this, you've got to draw it in 3D, and you've got to see the fluctuations going up and down like that. So it's got a trail coming off it like this here, like that. And that, the cone coming off the end of it, it's not perfectly spherical because the sun's going. So it's a nice curve like that. No, it's not. It expands and contracts itself like that. Yeah, goes like that because the sun's throbbing, just like the universe. But the universe is continuously expanding and will never stop expanding. But this is in a small section of the universe within a gravity plane called the solar system. So it's a little bit different to the singularity at the centre of the entire galaxy. It's a little bit different to that. It's not quite the same, it's just slightly different. That's why we're alive and breathing and not being sucked into a singularity. Self-gravitating devices. Like those people that think they can take off, they go to seance and you see someone take off, ooh, I can take off. Well, they're just copying the aliens that attacked us 5,000–6,000 years ago. They could take off with self-gravitating biosuits. The suit they put on, inside the suit, it's got a heating device to keep you nice and warm, it's got a breathing device to take the oxygen to let them breathe their atmosphere. Or if you're in a nitrogen atmosphere, like, I don't know, Uranus or something like that, like here, or methane, or whatever it is on Uranus, it converts that and gives you whatever you need. So if we built one of these, we'd want oxygen, wouldn't we? And to expel the carbon dioxide. Yeah, so we'd take nitrogen and methane in, convert that into oxygen, breathe the oxygen, breathe out carbon dioxide, take the carbon dioxide, get rid of that and fuck it off out, and it'd heat you. And if you wanted to, well, there's a mountain up there, you want to walk up there, do you? You know what I mean? It's like 5 miles, mate. You've got 25 minutes left.